Hello again, I'm Dr Sergis from the Dr Sergis Academy. I'd like to prove yet another circle theorem, the one whereby the angle between the tangent to a circle and a chord is equal to the angle subtended by the chord at the circumference. So for example, if we draw the circle, okay, and we draw a tangent, that is a line that touches the circle. Okay, so a line that touches the circle is a tangent, and it touches the circle at only one point because the line has no thickness, so it's only one dimension. Now if we draw a chord, so that is a line from the point at which the tangent touches the circle to the circumference, let's call that angle, call it angle X. So the angle between the chord and the tangent, let's call it X. And if we draw two lines that meet at the circumference from the chord, from the extremities of the chord, got two lines that meet at the circumference. We're claiming that this angle, which we'll label as A, we're claiming that the angle between the tangent and the chord, so any line that passes through the circle is the chord. And of course, a line that passes through the center is a chord that passes through the center is the diameter. So this is just a plain chord because it passes through the circle. Any line that passes through the circle is called a chord. Now, the chord subtends an angle, let's call it A, at the circumference. Now we're claiming that the angle between the tangent and the chord, label it as A, X, is equal to the angle subtended by the chord at the circumference. In other words, we're claiming that X equals A, as shown on the diagram. Okay, so to prove this, that the angle between the tangent and the chord is equal to the angle the chord subtends at the circumference, then what we do is we draw a line through the center, that is, we draw a diameter. So let's call the center O, is the center of the circle. Yeah. Now, we know from my previous circle theorems, which I proved, that the angle between the diameter and the tangent is 90 degrees. Okay, so the angle between the tangent and the diameter is 90 degrees, or another way of saying the angle between the radius makes 90 degrees to the tangent. So the radius makes an angle of 90 degrees to tangent. Okay, so now if we look at this angle here, which is subtended by this chord, so this chord subtends another angle at this point of the circumference. Just like this chord subtends an angle A, it also can subtend an angle, let's call it B. Okay? Let's find what that angle is. Now we know the diameter subtends an angle 90 degrees at the circumference. And I proved this from one of my earlier circle theorems. The diameter of a circle subtends an angle of 90 degrees at the circumference. So we know that's 90 degrees. So we've got the diameter here, which is the chord that passes through the center of a circle, is called the diameter, makes an angle of 90 degrees at the circumference. The diameter makes an angle of 90 degrees at the circumference. We know that from one of my earlier proofs. Okay, so therefore, and this angle, remember, if this angle from the diameter to the tangent is 90 degrees, then surely this angle, let's label it in red, this angle here must be 90 minus x, because that's 90, this angle from the radius makes 90 degrees to the tangent, the radius makes 90 degrees to the tangent, so therefore this angle must be 90 minus x. That's 90 minus x. Okay? So we can, because we know the sum of the angles inside a triangle is 180 degrees, so this angle and this angle, so we're looking at this triangle. Let's label the triangles A, B, and C, and this, and let's label this point D. So we look at the triangle A, B, and C. The sum of the internal angles, as always, in a triangle add up to 180 degrees. So let's look at, so we're looking at this triangle A, B, and C. So angle B must be 180 degrees, because these three angles of the triangle A, B, and C add up to 180 degrees. So 180 degrees, take away these two, 90 and this, must leave this angle. So it's minus 90, which is 90 there, minus 90 minus x. So we're taking away from 180, because these three angles have to add up for triangle A, B, and C, have to add up to 180 degrees. So 180, take away this angle, take away that angle, will leave us with this angle. So therefore, angle B must be 180 minus 90, minus, take away minus and minus 90, minus times minus and plus, that's 180, minus 180. You've got two numbers of the same sign, you add them, keep the sign. Minus 90 is minus 180 plus x. And now it will be 180 equal 180 is 0, so x. So therefore this angle must also be x. Yeah. So this angle, so therefore this angle x is also this angle. So in other words, the angle subtended between the tangent and the chord, the angle between the tangent and the chord is x, but it looks like the angle subtended by the chord is also x. So the angle between the tangent and the chord is x, which is also equal to the angle subtended by the chord at point C, by this chord AB. But from one of my earlier theorems, we know that the angles of points from the same segment, so the angles in the same segment are equal. So this is the segment here. So that's the segment. So angles in the same segment are equal. So therefore, A must also be x. So we're going to say that as angles in the same segment of a circle are equal, therefore angle A equals x. So therefore A must also equal x. And that's proven that the angle between the tangent and the chord is equal to the angle subtended by the chord at the circumference. Thank you.